Hey everyone, it is Gabe from Babylon Journey, and we are diving into episode 3. Hope you like my snazzy new video intro. But let's dive in. In the first episode, we made this demo, and in the second one, we made this, which was a cool exploration of the basics of lights in Babylon. But in this demo, we're going to make this, which I know doesn't look super fancy, but it's a demo that's going to give us a chance to get into a few concepts that we haven't gotten into yet. Namely sound. So this demo is a little sound gallery. I make music myself, by the way, but this was just a way for us to make a space that involves spatial audio. So this is audio that when you play it, it'll actually be louder the closer you are to it in a scene. So we're going to see how to create sound, how to make it spatial. We're also going to learn a little bit more about the Babylon GUI system. Remember, in this demo, we did a little bit of GUI with this little interface down in the bottom that just made a little text. Now we're going to make buttons that are linked with meshes in the scene. Anyway, should be a lot of fun, and let's dive in. Now, just as always, I've got two Code Sandbox links in the YouTube video description, one for the starting project, which is right here, and another one for the final project, if you just want to grab the final thing and start editing it and tweaking it. But if you're starting from scratch with me, just go ahead and fork that starter project, and let's go for it. So in the starter, this is all that I have. I've got some, just as usual, I've got my imports, which is various classes I know we're going to need from the Babylon library, some imports from the Babylon GUI, and I've also imported my songs, like my MP3 assets that I've uploaded into the assets folder so that we have some sound to work with. And for that little background you saw, just like we did in demo 1 with that forest background, we're going to do another background. This is with a canyon file, canyon.env, which is just another nice little background that I found. And I found this, by the way, in the Babylon repo. There's a folder with all sorts of cool public assets, and I found these .env files there. I'll include a link to this in the description as well. All right, let me get a sip. Okay. Let's dive in. Now, the first thing I want to do is actually set up that background. Now, in episode 1, we did this with create default environment, and we passed in the skybox texture. I want to use a different helper function this time, and this is going to be scene.create default skybox. So first, I'm going to say texture. And we need to kind of define a cube map texture, which just a cube texture. And we pass in our file, and we pass in the scene. And that's it. That makes a texture that we can then use in a different helper method, not create default environment, but just create default skybox. Now, why would you want to use create default skybox instead of create default environment? Well, if you remember, create default environment also created like this ground for us, but I don't want to do that. I really just want a skybox. So this create default skybox one is kind of better for that. You can just pass in your texture. The next parameter is whether it's a PBR material or not. This one's not. We're going to get into PBR later. And then the third parameter gets into how big, the scale of the skybox. And I want this to be pretty big, so I'm going to say 1,000. So that alone should actually create the skybox. Does it show up in our preview yet? I don't think so. And that's because we're not yet even running the render loop for the engine. Remember, every Babylon scene, if you want the scene to show up, you've got to run the render loop of the engine. Let's go ahead and do that. Engine.run render loop. I really should include this like in the boilerplate, I guess, but let's just get it right in as soon as we can. Scene.render. And I think now something might very well show up. If not, I've got theories. Okay, the error is actually helpful. No camera defined. And that was my theory. So we need a camera in here. Now this is going to be fun. Another new thing for us to learn. In our previous 2 episodes, we've been using the arc rotate camera. Remember, that's this camera that kind of rotates around a particular pivot point. You set a target and it rotates around it. Well, for the demo we're making, I want the user to be able to kind of walk around the scene, like not just rotate around a particular object, but actually move around almost as if they were a character in a video game. So we need a different kind of camera for this. That's why my camera import is a universal camera, not the arc rotate camera. So this is another class from Babylon. It's a specific camera they've made that comes with all sorts of cool behaviors already into it. So for our camera, let's say new universal camera. It's just a class, so we're making a new instance of it. Let's give it a name. We can just call it like player camera. And the second argument for this constructor is just the position that you want, the starting position of this camera in the scene. So let's just say, let's start it at 0, 1, 0. This will start it at the origin point of the scene, but up 1, right? It's 1 in the y-axis, positive 1. So it'll be up above the ground. Okay, lovely. And then I believe, as usual, we pass in the scene so it knows which scene to be a part of. And let's say, as always, we need to attach the canvas to the camera so that it knows which canvas to, when you click and drag on the canvas, to kind of manipulate that particular camera. Now let's see if we get our preview. What's a good tip? You need a camera to render the scene, really. Otherwise, it's not looking out of anything. Okay, so here we are. Not the most crisp background, but that's okay. We don't need it to be super crisp. We just need something in the background. And this looks fine. Okay. Now, our camera is actually here. The universal camera, you can move around the scene using the arrow keys of your keyboard. But the skybox doesn't really have a sense of depth, right? It's not like a 3D model. It's just an image kind of mapped around the camera. So it's not as if I can move forward or backwards, really, and notice it. Actually, am moving forwards and backwards. You just don't notice it. But you'll see when I rotate around the camera, instead of rotating the camera around a particular object, I'm actually looking around. That's different than the arc rotate camera. Okay, let's dive in. So let's create a ground. And I wanted a ground that was different than that default ground from the create default environment. That's why I broke the skybox out, making it on its own instead of using create default environment. And also going to break the ground out into its own thing that I have a little bit more control over. So Babylon has a function for create ground, just like the create sphere and create box and create, all these kind of helper functions to create common things, and create ground is one of them. So let's do create ground, and I'm going to call it ground, and you pass in some options. One of the options is height, let's say 50. One of them is width, 50. And then another one is subdivisions. And this is kind of like how complex you want the geometry to be. We don't need it really complex, it's just a ground. So I'm going to say 4. And let's just see how that looks, our ground. Okay, here it is. Yep, doesn't look fancy, but is what it is. We have a ground. Notice now, you can actually notice me moving the camera. I'm using the arrow keys to move our universal camera, and it's kind of quickly moving off this ground, right? Almost too quick. Whoa, what are we going to do here? Now we got two options. We can make the ground a lot bigger, or we can slow the camera down. And I'm going to go for slowing the camera down. So there's a speed property on the universal camera. We can just say camera.speed equals 0.01. I think the default is 1. We're going to make it 1/10 as fast and see how that feels. Okay, that's a lot better. I'm not immediately moving off of the ground. I'm moving. Now it's hard to tell because there's just not much else in the scene. But you'll see that eventually I do get to, I should be getting to the edge of this map here. Maybe I made this camera too slow. But it's going to be hard to tell until we have more things in the scene so that we can see their relative position to the camera. So let's keep going. All right, let's make a, we actually want to kind of create like a sphere for every song, right? We're making a little gallery of audio, and each song is going to have its own little sphere and user interface to play and stop. So we want to do something for each song. So we've got I made a songs array here that just is an array of objects. It's got the URL. This is really just the source of the song from my import. And then I also give it a title, the actual title of the song. So simple little array of objects. And I want to sort of loop through it. And so let's do songs.forEach. We're going to do a nice for each loop. We're going to say for each song, do something. Now, what do we want to do for each song? Well, for starters, let's make a sphere. Let's make our sphere. Sphere equals create sphere, right? Just like create ground, it's a Babylon helper function for create sphere. And let's call it song sphere. And we pass in some options. The only option I want to really set is the diameter of the sphere, which is 1. And remember, each one of these has different options you can use. Right? Ground has these specific options. Sphere has a different set of options. And diameter makes sense for sphere and not for ground. Okay, and also let's do our scene. Okay. Let's see what this looks like. So we're saying for each song, make a sphere. Fair enough. Okay, well, it doesn't look like much. Like, where's my sphere? What's going on? And checking back, got a theory that we're actually going to need a light in the scene in order to make stuff really show up. Because if this sphere was showing up, it wasn't lit. I mean, it would look like this ground, just black, like it wouldn't even be distinguishable from the ground. So, silly me, we need a light in here. Let's go ahead and do it. Let's make a new hemispheric light. And for a hemispheric light, this is just the constructor itself, we're going to call it hemi-light. And the argument it takes here is the direction of the light, which is usually just kind of like upwards. So we can say 1 in the y-axis, fair enough. And then our scene, let's see what things are like now with our light in the scene. I'm expecting maybe the ground to look a bit different. Yep, instead of black, it's sort of this, it's lit up. And our spheres, still not visible, so let's see. Well, what's the position of the sphere? I'm not setting it, so it's going to default to 0, 0, 0, which might be kind of like in the ground awkwardly. So let's just say sphere.position.y equals 3. I'm hoping to see a sphere up above the ground now. Oh, there it is. Okay, lovely. Boy, that is looking pretty big. Okay, fair enough though. We've got our sphere and it's showing up. That's a good start. Okay, now the next thing I'd like to do is actually get our sounds started. So I'm going to make a constant called sound, and we've got to make a new instance of the Babylon sound class. Right? For each song, we're going to do this. We're going to make a new sound. So sound is a Babylon class, and this is what you can use to kind of make sound files. Now, we're making websites, right? In theory, if you wanted to just use native, like web audio stuff, like the typical APIs you might be interested in using, like you could. But the reason why you'd want to use the Babylon sound class is if you want to do things like spatial audio, right? Like audio that really leverages the 3D aspect of the site you're working with. So it makes sense for us to use it. Now we're just going to give each sound a name. We're going to call it song. You've got to pass in the source, kind of the source URL. It can be an array buffer, as they say. The source of our song we actually have, if you remember, in our songs array, where I put the kind of the imported audio, I pass it into this URL key. So we can say song.url, because we're doing a songs.forEach song, and I need to include this in the for each loop, not outside of it, so that we actually have access to it. Perfect. Okay, and we do scene, and I believe the next, you can pass in a ready to play callback. This is like once the audio has loaded, you can run a function to like a little callback. We don't need anything here actually, so I can just say null. And then there's an options object that you can pass in a bunch of different options for. For us, we want to say autoplay false and spatial sound true. This is also where you can set things like loop if you want the audio looping. Again, other things that you're used to actually from like native audio like browser stuff, but some other special ones like this one, spatial sound. So we want spatial sound to be true. We want the audio to get louder when you're closer to the sound. Okay, lovely. And I want to be able later on to stop. Like when I play a song, I want to stop any other sound that's playing. So it's actually going to be helpful for us to store the sounds in their own array so that I can loop over them later. So I'm going to say const sounds equals an empty array. And for each sound, I want to do two things. First, I want to push the sound to our sounds array so that I have it for easy access later. And I want to do this very key function, sound.attach to mesh. And I'm going to attach it to the sphere that we just made, right? Okay, so recapping, I've made a sphere. I've given it a position. This is for every song I'm doing this, making a sphere, giving it a position, making a sound, pushing the sound to our sounds array, which we're going to use later, but then very importantly, attaching the sound to the sphere. This is where we let Babylon know, like, okay, we've said, hey, it's spatial sound, but this is where the audio, this is where the sound's going to be in the scene. We're going to attach it to the sphere. This means that if we move the sphere around, the audio would actually go with it in terms of the spatialization, right? If you attach a sound to a sphere and that sphere moves far away, that audio is going to get quieter. Pretty cool. Okay, lovely. Now, this itself won't actually start playing the audio because, for starters, I've turned autoplay to false. And also, I don't think we'd want it to because I'm doing this for every song right now. And if this were to just play out of the gate, then all the songs would play at once. And that's not what we want. And in fact, what we want are buttons so that the user can control which song is playing and also be able to stop that. Now, if you think back to this demo from episode 2, we made a full screen UI and attached this little bit of text kind of to the bottom of it. That's a good start, but we're going to do something different with Babylon GUI, and that's, instead of making a full screen UI, we're actually going to make UI that's like linked to elements in the scene so that each sphere below it can have little buttons for play and stop. That's different from a full screen UI, which kind of gets like overlaid on top of the whole scene. We're going to make like in-world, like in-scene UI, and it's going to be a really key thing for you to learn. So let's dive into it. All right, first off, we want to actually create like a plane. It's going to be sort of like the holder for our UI. Now with full screen UI, the holder was the full screen UI. But if we're making UI in-world, we actually need like an in-world sort of container for the UI. And it's going to be a plane. We're going to use a helper method, create plane. We did create ground, we did create sphere. Now we're doing create plane. We're going to call it plane. And for the options object, we can do height and width. We're going to say height 4, width 4. Should be big enough. And then as always, scene. Okay. Now, we want this plane to be attached to the sphere. This is kind of, we want the plane to be right below each sphere. So let's go ahead and just do plane.parent equals sphere. Okay, now parenting is really important, and we're going to have an episode that dives into this more, but in a nutshell, when you make the parent of the plane the sphere, the origin point for the plane actually is the sphere, not the general origin point of the scene, which is 0, 0, 0. So this will make the plane actually show up like right with the sphere. And I'll show you what I mean. Let's check the preview. And parenting is really cool. I mean, if we were to move the sphere around, the plane would actually come with it. Okay. So look at this, right? Because the plane is a child of the sphere, like it shows up linked with the sphere, right? It's a child of it. You move the sphere around, the plane comes along for the ride. Now, I don't want it really intersecting like that, so we actually do want to move the position of the plane down. And let's give it a position, new vector 3, 0, minus 1.5, 0. Now, if the plane wasn't parented to the sphere and we gave it this position, minus 1.5, it would actually show up underground. We wouldn't be able to see it. But because the sphere is the parent of the plane, the minus 1.5 is relative to the sphere. The plane will show up underneath the sphere. And that's actually kind of what we want, right? It's minus 1.5 compared to the sphere, which is already up, I think, like 2 or 3. So that's why we still see the plane in the space. Again, if the plane was not parented to the sphere, we just wouldn't even be able to see it right now because it would be underground, minus 1.5. Okay, awesome. Now, we kind of want this plane to be like the container, as I said, like our in-scene container for some user interface elements, some buttons. And I'll show you how to do that. We're going to make an advanced dynamic texture. And before, in the previous lesson when we did this, we, again, made a full screen UI, like we did a create full screen UI. But now we're going to do create for mesh. This will create that advanced dynamic texture that can hold the GUI, but kind of like build it on a mesh target instead of making that full screen one, which is really cool. And you just pass in the mesh you want. And I want to use our new plane that we just made. That's what we're going to do. Okay, cool. Now, the advanced dynamic texture alone is nothing until it actually has like GUI elements on it. So let's go ahead and make some. First, let's make a stack panel. Now, stack panel, this is a new GUI element we're working with. Stack panel is what you can use as just like a container for many different things. And it'll flex its height or width depending on how many elements are in it. So it's sort of like generic kind of container that you can use if you know you're going to be adding a few other things to the GUI and you want it to flex in height or width kind of automatically. So we're going to make a stack panel. And then we're going to add this stack panel to our advanced dynamic texture, which is our overall GUI container. We're going to add control panel. We did this before in episode 2, but add control is this way that you kind of like add GUI elements to different containers. Okay. Now, first thing I want to actually have in this, stack panel is a header. Let's go ahead and say const heading equals new text block. Now, we're familiar with text block from before. I'm going to give it a name, heading. And the second argument here is actually like what you want to show up in the text. And for this, we want our song title. Okay, so I'm going to say song title. I'm going to use a template string and then pass in the song.title. This is from our, we're doing songs.forEach. In our songs array, we've got a title key where I put in the title. Okay. So that'll give us our heading, but let's style it a tiny bit just so that it pops a little bit. We're going to say heading.height. These are all properties on the text block class. Okay. I'm going to say 110, and let's say heading.font size. I don't exactly know how big we want it, but let's say 50 for now. And let's say heading.font weight, just to make it a little bit thicker. We'll say 700. And let's say heading, let's give it a little bit of padding at the bottom. Padding bottom in pixels equals 30. You can do padding in GUI either with percentage or pixels. Sometimes when you're using stack panels, you need to use pixels in certain cases. Okay. And then finally, panel.addControl heading. So we've made our panel. we've added it to our overall GUI container, which is this advanced dynamic texture. We've made a heading, then we've added that heading to our panel. What does this look like already? Let's take a look. Okay, it is telling me that I've done something bad. I've made a stack panel without actually using new. That's silly me. Stack panel is a class just like all these things, so I need to do new stack panel, not just stack panel. Fair enough. All right, here we are. Let's see. Okay, this is actually looks garbage, but is actually what we want. The reason why it looks garbage is because remember, it's doing this for every song, and I've got 10 songs in my song array. So it's doing this for every song and kind of plopping them right on top of each other because the position for all of these is the same. So let's actually go ahead and change this now to where these are actually split up visually, positionally in the scene so that they're not all lumped on top of each other, because that's going to be hard to work with if they're lumped on top of each other. Okay, to do this, let's go back to position. We're kind of hard coding it here, sphere.position.y = 3. It's a little high up, let's do 2.6, but actually what we want to do now is I want 2 rows of spheres. Like a user can walk down and to the right they see some songs and to the left they see some songs. So how are we going to do this? Well, I'm going to say for all the spheres, kind of the first bunch of the spheres, we're going to need the index here actually in our for each. The index is just the numerical like kind of order of the items in the array. In a for each you can access the index. So if the index is less than 5, like for the first 5 of them, then let's do sphere.position = new vector 3, -7 on the x axis. That's going to put it, remember x is side to side. So if my camera is around 0, 0, 0, then -7 is going to be 7 in this direction. Over to the left, that's going to be my row over to my left. And then 2.6 for the y-axis, that's how high it's going to be. That can be the same for all of these. But then for the z value, forward or backwards, that's where I need it to be different for each one. I'm going to do the index times 6. But then for the second group of spheres, my second row, I want that to be to my right. So my new vector 3, instead of -7 for the x, this is going to be +7. That's going to be to my right. I can do the same thing for the height, which is 2.6. But then for the index, I want to do index -5 times 6. That'll kind of give me the same z values as this one, but because the index is so much higher over here, I need to subtract 5 from it, and then it'll kind of even out. And let's see if that was right at all. Now, fingers crossed. Look at that, beautiful. We've got a row over here. This is -7 on the x, and over here this is +7 on the x. They all have the same y value, which is why they're all the same height. And the z value is where they are forward or backwards. And this is the one that we needed to be different. We really needed to space this out, and we did that pretty well. And look, now we can see our song title in the heading. Now I'm noticing a few strange things about the camera behavior. I'm noticing that if I look down and move forwards, it actually moves me through the ground. Boo. I don't want that. This universal camera is a little too free for me. I've got to lock it down a little bit. So let's do that up here with a, remember the function we can use to make something run every tick, every frame, before every frame renders, on before render observable dot add. And we're going to add, basically we want the camera position equal camera.position.y equals 1. We kind of want it like just bring it back to 1 every frame. So this should really prevent the user from even being able to move beneath the floor. because every frame we're running this update, right? Look, I'm looking down, I'm moving forwards, it's not moving me down. I'm looking up, it's not moving me up. I'm kind of locked this way, so I can only move on the x-axis and on the z-axis. Awesome. Okay, let's bring this thing home. We haven't actually heard the audio yet. You're probably wondering, where are these sounds? It's not because I'm ashamed of my music and I don't want you to hear it. It's just because we haven't built a play button yet. So let's make it. We've got our heading on our panel, but let's add a few more things. Remember, a stack panel will automatically just adjust. You can just attach controls to it and it'll just stack them up. And you can have them be vertical or horizontal, by the way. The default is vertical, that's what we want. Under the heading, we want play and stop. Let's do it. So let's make a play button. Now this is going to be from the button class in the Babylon GUI. There's a special helper function for just making a simple button. That's all we want. So we can call this method create simple button. And this is handy. I believe we give a name to the button. And let's give it a name, play button. And then you actually just set the text that will show up on this button. And the simple button is literally just like a simple text button. So we're going to say, there's our play button. Let's give it a little bit of style. Play button, we'll say .width equals 0.5. Now, if you don't set width in pixels, that means you're using percentage mode, the value between 0 and 1. I want this to take up half of the value, half of the width of its container. So that's percentage mode. We'll give it a height. This will do in pixels. And let's give it a color. Let's say white. That'll be the text color. Let's give it a background color. Background green. Let's give it a font size of 40. The other one was 50, so it should be a little bit less, I think. And let's give it a font weight. Also make it nice and thick. 700. And now we actually want to make something happen when you click on this thing. So how do we do this? Well, we have an observable for this. Remember our scene observable? That was like a observable you add on the scene. This was on before render, so fires like before every frame renders. Well, GUI elements have their own set of observables. And for this, we want on pointer up observable. Now there are lots of these observables. We're going to go over all of them, but there's on pointer down, there's on pointer move, like for kind of hovering. There's a whole lot. For this, we want click. It's on pointer up, right? Pointer goes down and up. And when the pointer goes up, we want some code to execute. So we want the on pointer up observable, and we're going to do add. And there, now we make our function code to run when the pointer goes up on this play button. And we want to loop through all of our sounds. Remember, we kept a sounds array that stores all of these sounds. And basically, when I click play on something, I want to make sure nothing else is playing. So I want to stop anything else that's playing. So I'm going to do sounds.for each sound. And for each sound, I want to stop it with the stop method. This is a method on the sound class. But then, after that, I want to actually play the sound that is on this particular, in this particular loop. Remember, we made for each song, we've made the sound, push it to the sound array, attach it to the sphere mesh. Well, that's the one I want to play after I loop through all the sounds and stop them. So let's see if this works. Might be the very first, we're like a half hour in, might be the very first time we actually hear something in the demo. Fair enough. All right. Ooh, I still don't see my button, and I guess that's because I probably didn't attach it to the panel, like a noob. So I need to do panel.addControl, just like I did panel.addControl heading. I need to do panel.addControl play button. Here we go. Here we go. And let's push this, see if we hear something. Not quite, because I see sound.stop is not a function. Well, that's kind of strange, because I believe that it is. Let me see what's going on. Sounds dot for each sound, then do this sound dot stop, and let me make sure that I'm doing this right, pushing my sounds dot push, sounds dot push sounds, but I want sounds dot push sound. I had a little typo there. Fail. Let's try it out. Not perfect by any means. All right, here we go. Let's try it out. Moving close to say, ooh, I want to play this song called Here to Stay. Let's see what happens. Oh no, let's play Orpheus. Okay, now you'll see this little button pop up here. This is a little like button that the browser needs. Like it needs to detect that the user has interacted with the scene. I just click that, and then when you click play, here we go. It's the song. And if we pick another song, it should stop any song that's playing and then play the new one. So let's see. Amazing. And you might be thinking, why is it coming so loud out of my right speaker? Maybe you can't hear that, but I can. It's because the audio is spatialized, stereo spatialized. And when I move my camera over so that my left ear, so to speak, is towards that audio, that way, then I hear it in the left speaker. When I'm looking right at it though, it's even, and when I get closer to it, it's louder. Amazing. Okay, let's refresh so that the audio stops so that you can still hear me. And finally, let's just make a little pause button right below this. I'm gonna copy pasta the entire play button and bring it down here, but instead of a play button, it's gonna be pause button. Copy, paste, 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 paste. On the pointer observable, all I wanna do is this particular sound dot stop. And instead of this being saying play on it, we want it to say pause. And instead of giving it a green background, let's give it a red background. Otherwise, I think this is good. Let's save it and see how it looks. Oop. Just as before, I need to actually add it to the panel with add control, pause button. All right, let's see what we got. Okay, there we have it. Now, one last touch. When I move around, I'm kind of unable to really see these buttons, like really read the text that's on them. So I'm going to show you a fun trick, and this is called billboard mode. Basically, billboard mode gives you the ability to make meshes always face the camera, which is really handy. And we totally want to do this. And we can even put this right on the sphere itself. So for the sphere, I'm going to say, oh, we don't need this position anymore because we're doing the position up here. But I'm going to say sphere dot billboard mode equals 7. Now you can hover over billboard mode to see all these different options for it. 7 just means we want it to be billboarded on every axis, no matter what direction the camera is from it. Make this thing face the camera. So check this out. We do this in my product frame, by the way. You can set an asset to always face the camera, and this is the way that we do it. So now look, when I move, this thing moves so that it faces me. I always have these play pause buttons, really easy to interact with. They're not statically set in terms of their rotation. They will look at the camera. All right, so there we have it in about 30-35 minutes, I hope. A little demo with spatial sound. We made a little audio gallery, simple little background, simple little floor, but just showing you the basics of sound and also some in-world GUI using advanced dynamic texture create for mesh instead of create full screen UI. Okay, thanks for following along. Next one soon.